Boom! Yes folks, Hume again, how are you going? In this video we're going to talk about binary operators. Alright? Binary operators, strangely enough, even though it will be a new topic to people meeting it for the first time under that title, it is something that you would have been doing before. Unbeknownst to yourself, you were not even aware that you were doing it. Anytime you multiply two numbers, that is binary operations in action. Anytime you divide one number by another, that is binary operations in action. You add two numbers, that's binary operations in action. You subtract one number from the other, one number take away the other number. That too is binary operations in action. Now, the operations themselves are not inherently binary. They are binary when they are applied to two entities alone. Right? We know that the prefix bi means two. So if you multiply three numbers by each other, that is not a situation where you have a binary operation. The operation is only binary if it is applied to two entities. Understand that? So we have been doing it. We have been doing it. You're learning at tables. Excellent example of binary operations in action. All the tables that we learn at the back of the copybook, from 1 timetable to 12 timetables. Two numbers multiplying by each other. That's binary operations. And of course the flip side is that you're dividing, that's two numbers as well. 9 4s are 36. 9 by 4 is 36. 36 divided by 9 is 4. Or 36 divided by 4 is 9. In each of those three cases, you interact in two entities. That is binary operations. If we're talking about the operations, we also have to talk about the operators. What are the operators? The operators are simply the symbols that we use to signify the operation. So for example, if we have this, we know what that means. As soon as we see that, we know that that signifies multiplication. So this is the binary operator that signifies multiplication between multiplication of two elements. Or, let me put it another way. This operator means multiplication. If we multiply two elements, then it becomes a binary operator. Right? And then in that case, the operation is a binary operation. Same thing for addition, same thing for subtraction, same thing for division. Right? These are what I would refer to as familiar operators. We know what it means. Even the people who claim to have problems with maths, as soon as you see these symbols, you know what they mean. These are familiar operators, signifying familiar operations. Right? Now, if you're operating on something. Right? So the thing that we're operating on, to use the terminology, the jargon, the thing that we're operating on, we call that the operand. Alright? So for example, if we see this multiplication sign, as soon as we see that, we know that if we have a x, curly x, with a multiplication sign and then a y, we know that means x multiplied by y. If we have x plus y, we know that means x plus y, we add in. X, take away y, we subtracting, and of course we have x divided by y, that is division. Operator, sign, this whole thing here, this would be the operation, that is the process. Right? And then we have the operand. The x is an operand, the y is an operand. And that is the case in each of these 4 operations. Those are the things that you're operating on. All right? As you can see here, you have what we refer to as generic operands. Right? In the language of algebra, we refer to them as variables, simply meaning that you don't know what the value is. So in other words, this x could be anything, and this y could be anything, depending on whatever situation you find yourself in. So for example, if x is 8 and y is equal to 4, then what we have here is 8 multiplied by 4, right? What we have here is 8 plus 4. What we have here is 8 minus 4. And what we have here is 8 divided by 4. All right? So you have 2 operands. In each case, the operands are the same, right? We have a generic value. And in each of these cases here in red, we assign a specific value to each general value. So we assign the value 8 to x, we assign the value of 4 to y, and we then subject these values to the same process, the same operation that is being described by each of these operators, right? Multiplication, addition, subtraction, and division. So all of that to say that we do in binary operations a long time. We understand the process so intuitively that we don't even know that we understand it, at least at the basic level of these basic 4 operators. But like most things in maths, it starts simple and then it gets more complicated. All right? Because apart from the simple operations and the simple operators and the simple operands, we could get more complicated in each of those things. So for example, we have a whole host of other binary operations in maths, some of which most of the people looking at this video might never have to use. All right? We have things, for example, like vector addition. Right? That is something that a typical school student doing maths would have to deal with at some point. Vector addition, matrix multiplication, yeah? And then you have exponentiation. Indices, your powers, you raise something to a particular power, etc., etc. Right? So those are 3 examples that most mathematics students will come into contact with at some point later on in their mathematics journey. Of course, there are other things beyond that we wouldn't even mention in this video. All right? So apart from the fact that you have simple operators, simple operations, and simple operands that we are familiar with, leading to more complicated ones, there is also the possibility that anybody, me, you, anybody, we have the opportunity to define our own operations depending on whatever it is we want to do. All right? So it is not just simply a matter of the known and established mathematical operations, the known and established mathematical operators, the known and established mathematical operands. It is also a case where you, yes, you, could define your own operation. And we could start by defining the operations as a combination of other simpler known operations. Right? So we have these 4, for example. We could define a whole new operation that involves a combination of those 4. We could define a whole new operation that involves a combination of these 4 with some others, things like squares and square roots and all them kind of thing. Right? Reciprocation, where you flip a fraction, those kinds of things. There are a lot of little things we could slip in there. All right? So I will leave that for the video following this one. All right? I try my best to chop up the videos a little bit So I give everybody a chance to look at little pieces at a time, think about it, focus on it, and then they move on to the next step. So in the next video in this series, we will deal with the specific case of defined operations, operations that you choose to define, operations that you define as combination of other simpler known operations. And of course, if you're defining a new operation, you will run into the problem of deciding what is the symbol, what is the operator, right? And even over there, in the same way that you could define the operation on your own, you also have the total freedom to choose whatever symbol you want to define the operation. All right, whatever operator you want, you could choose your own operator in the same way that you could choose your own operation. But we will deal with that in the next video.